The first swimming flume in the GDR. Constructed in 1972. It was the first flume in the world to be used for the analysis of competitive sport. A closely guarded secret at the time, and now 35 years later, it's technically obsolete. The TZ Technisches Zentrum is assigned the task of designing and constructing the most technologically sophisticated flume in the world, alongside the old location in Leipzig. Politicians and sports officials undertake the ceremonial groundbreaking on the 21st of March 2007. Conventional training is no longer sufficient for the highest level of sport. Instead, these methods are the only way in which the last reserves of performance of sportsmen and women can be identified and utilized. Consequently, top-class sport and top-class technology form a single unit here. The following film shows the construction work up until the day of opening. Wigan Fitzner, in conversation with his engineer Frank Sellin. The 69-year-old has been involved with flume facilities for over 30 years. He explains the structural principles of the flume and the water cycle in simple terms.
Die Zeichnung hier hinter mir zeigt
The drawing behind me shows a flume for swimmers. However, all you can see in the hall is the pool where the swimmer trains and the coach moving along the edge, keeping an eye on things. This pool also includes additional equipment for disabled people. As competitive athletes generally jump in here against the water current. The water enters the pool here at a constant flow rate, which means that there are no points with different water speeds. Here at the rear, it is diverted via appropriate components, all made from stainless steel. The whole pool is made of stainless steel, in different directions, and the air is pumped out at these points. The water stream generators come in 3 different sizes, ranging from 22 kilowatts to 75 kilowatts per generator, depending on the requirements and the speeds in the flume. Here we have the axial flow pumps, which are large propellers within appropriate mountings that are responsible for transporting the water back. There is additional equipment that ensures equalization, that is, extracts air again. You can see it here in the external pipes. And here we have grills and paddles that are responsible for directing the water upwards again. This is where the flow is precisely aligned to ensure that the water returns to this point here. The whole unit consists of individual modules welded together to make up the flume. Up to 35 tons of stainless steel may be processed to make one flume. The whole unit is then encased in concrete in order to eliminate vibration. And now it is a really massive structure. A flume for swimming can be up to 14 meters in length. Other flumes, such as canoe tanks, are bigger. The width here is 4 meters, easily allowing 2 swimmers or 9 patients to use the flume at the same time. All sounds very simple, and it is. Well, almost. After the concrete base plate has been prepared, the individual stainless steel elements are added. Here you can clearly see the paddles that will later divert the water from bottom to top. The first diversion casing is installed. In the meantime, in a factory in Pirna, 140 kilometers southeast of Leipzig. This is where the casing elements for the TZ swimming flumes are produced. On the one side, high-tech cutting equipment, on the other, highly specialized craftsmanship. Some casings are already ready for transport, others are yet to be completed. In Leipzig, the individual casings are assembled piece by piece on the construction site and then welded together. The casings themselves are reinforced and stiffened from within to avoid being dented when the concrete is poured in. Finally, the lower section of the flume is assembled and ready for the first concreting phase. A critical task. The concreting can only be performed in small stages over several days, otherwise the lifting of the concrete would tear the casings from their anchoring and weeks of work would be ruined. Consequently, the concrete sheath enclosing the lower flume section that will channel the water grows piece by piece. Sometimes the weather refuses to cooperate, but the lower concrete sheathing is finally finished. Here we see a so-called manhole. When not filled with water, the flume will be accessible from this hole for maintenance work. Whilst the concrete formwork is removed, further casing elements arrive. The upper casing elements are combined with the lower section. The swimming pool is created. Welding work follows. Here at the latest, the problems that the engineers and construction staff are faced with become evident. The construction trade is accustomed to working in centimeters, but we work in millimeters, and we have to coordinate this. We need to be accurate down to the millimeter, or the necessary quality of the flume will not be achieved. From this perspective, you can see the swimming pool at the top left. On the right below this, the flume sections that would later be non-visible, which are now ready for final concreting. The actual wall of the building is already visible as an outer frame. After this, the process is repeated. The concrete sheathing is built up successively. With the concrete casing complete, the propulsion units are mounted. However, before this, engineers fit the 4-meter shafts into place. These will later drive the propellers in the 1-meter 20 propeller shafts. At the other end of the flume, also in the cellar, is the space for water treatment. Here we see the swimming pool. The view from the large underwater window. Here the view towards the flowing water. The swim guard can be seen here. Welding work for the step anchoring point. The steps will later enable easy access to the basin. In the overview, one of the diversion casings is visible. A few months later, the building shell is nearly complete. Before the roof goes on, there are still final elements to be fitted, such as this rectifier and the moving bridge, which will later be moved to and fro over the flume. In the pool, the elevating base is being installed. The supporting elements support the floor of the pool. These will later be capable of being raised and lowered mechanically by 50 centimeters. The controls are operated via 2 buttons on the side of the pool. These initiate the mechanical propulsion in the cellar. This enables the floor to be raised or lowered in just 40 seconds. As soon as the water treatment facility has been installed, the underfloor heating laid, and the floor tiled, the flume can be filled with water. opening day. In addition to politicians and sports functionaries, top German swimmers are also in attendance. The focus of interest? Britta Steffen, double Olympic winner in Beijing. She's obviously familiar with training in swimming flumes, and yet the flume in Leipzig is different. The opportunities that Leipzig swimming flume offers are just fantastic. I'm tempted to come here more often. It is certainly a great way to train frequency, and this helped me a lot during the sprint training with my trainer in Berlin. We quite simply have to acknowledge that this here is much better than we have at home. We'll have to see how much we can incorporate it into our training program. 18 months after groundbreaking, Leipzig has the most modern swimming flume in the world, thanks to the TZ.